Watch me nay nay. Okay. Now watch me whip, whip. Watch me nay nay. Can you do?
One thing I've noticed that's different between the intro and the method class is that methods needs lots of examples. So with that introduction, let's dive right into another data set. This one is called rainwater level, which now that I write that out, that is way too big, and I do not want to call it that every time I try to use this data set. I'm going to call it instead rainwater level RWL. So what this data set has is the amount of electricity used, and that's what we want to predict based off the amount of rain they had and the season, which we have, it looks like summer, spring, and fall. There is no winter. This is clearly not a data set from Laramie. Otherwise, it would be called the snow water level, and it would be electricity, snow amount, and it would say winter, except for 3 spots that might say fall. So what's my goal here? Well, let me try getting a look at what this looks like. Okay, I see that there is a relationship between electricity and rain, but it looks like it's not linear. And I don't know that I see much here, but we'll find out. While I'm in the exploring phase, I'm going to say, let's look at electricity based on rain, and let's color it based on season, and this should tell me an awful lot. Oh, I have to say data equals rainwater level. Okay, I definitely see a curve between rain and electricity. Do I see a difference between the 3 different seasons? Boy, if there is, it's really hard to tell with this picture. So if I want to include all these variables, I'm going to make a linear model. Electricity is what I want to predict based on rain plus season plus rain times season. And because there's an R trick here, I can just do the times and I get the rain and I get the season. Data equals rainwater level. My next step should be to look at those residual plots. And if my window is big enough, yeah, I've definitely missed the curve, which you can see in this model up here that it's only linearly connected. So what do I need? I need rain times season, and I need rain squared plus rain squared times season. And the R trick says if I just do this, it'll throw in rain squared as well. Now, it's also throwing in season twice, but that's not a problem. R is going to recognize that season gets put in twice, and it'll only actually use it once. Let's try those residuals. That's looking much better. What you want to see is based on the residuals, it should be evenly spread. Now, it's true that there's more data where there's less electricity used, and using lots of electricity was something that only rarely happened. But based on the spread here, the residuals, do we see a pattern? And I would say no. In fact, some students might argue they're seeing a fan shaped here, but it's only because there's so much data here, there's some higher outliers that get to be there. Because there's less data here, there's not as much outliers. I wouldn't even say it's a fan shape. I'd say it's just an artifact of having more data here. Residuals look really good. The scale location version, of course, looks good. I say of course because it should have had some pattern show up here if it was also going to show up here. This might only emphasize patterns. Leverage, there's no single data point that seems off. Is that the dashed line? Do I have weird data? Okay, you know what? We're gonna just do these one by one. I wanted to avoid that. See, this looks beautiful. And that is fantastic. Good luck finding that with a real data set that's not made up. Yep, looks good. Alright. Oh, this is just part of the legend. I see. So somewhere there's dashed lines that say there's a data point that's a problem, and they don't even show up here. So this looks great. I feel like I have a good model. Let's go ahead and check out my summary. If I can size my plot without ruining R. Alright, I take back what I said about having a good model. Why? Well, let's take a look at what's not significant. The y-intercept between fall. Fall must be the baseline here. So between fall and spring, the y-intercept is not different. Between fall and summer, the y-intercept is not different. So changing the y-intercept really doesn't have any effect. And not only that, but changing the linear term seems to have no effect, although that 0.095 is kind of small. And changing the squared effect seems to have no benefit here. So let's try taking some of this out. In a future video, we're going to talk about how it's better to do this slowly and why. But for right now, let's just break rain squared and season. Okay? So right here, oh, you know what? I need to do a little better at annotating what I'm doing here. Okay, so now that they're not multiplied, there's not going to be this rain squared times season effect, which the p-value says it's not really helpful anyway. So we've shortened our list here, but you can still see how rain times season doesn't seem significant, and even season itself doesn't seem significant. Now, when you decide which of these to take out, I'm going to choose to take out the rain times season just because it's a more complicated term. When we get to the chapter on multivariate, we'll spend a lot of time talking about these kinds of decisions. So now our summary will have, look at this, still season is not needed. Where does it show up in our equation? Well, I added it in right here, and I added it in right there. Let's try this now. Oh look, now we have everything significant. But the fact that we deleted everything with season is meaningful. It means our data couldn't show that if you're trying to predict electricity, it helps to look at what season you're in, spring, summer, or fall. And logically, it might make sense that you would, except this isn't a real data set. So the point is, we have in our data set a column of information that really isn't useful or helpful. Now, one thing I want to do really quick is to go back and re-look at my residual plots. It should be that they don't look any different. The reason why they shouldn't look any different is the p-value said it really doesn't matter if you have this variable or not. But sometimes when you get going fast, you make a mistake. This is a good way to check the residuals to make sure I didn't mess up. Survey says, well, I've squished these so they're hard to see, but I think they're looking okay. They look great. They don't really look any different, which is what you would expect. So now in my document, how would I describe this right here? Well, I'd really like to have a picture to help me. What picture do I need? This right here is a very cool picture, but it has these different colors which aren't actually meaningful. If I'm not going to have season in my data set, then coloring it based on season really isn't going to help me. So let's take that out. Well, let's go back to this, and I'm going to put my prediction equation on there. So I start with the predicted rain values. I'm calling it rain hat, and elec hat, because electricity is just too big of a word to spell. And what's my equation? It's 33.15 minus the 27.68. I hope you can see where I'm getting this right there. And then that's times rain, which rain hat is what I'm using to make these predictions, plus 53.34247, that was way too many decimals, that's annoying, times rain hat squared. And let's do lines based off of rain hat, color equals red because I like red, really is the only reason. Oh, because I spelled something wrong. Hang on. Like hat. This is why we pause videos. Oh, that looks great. Let's grab this picture and we're going to throw him in there because I'm going to find that very helpful when I'm trying to describe this. So, what do I need to say? I need to mention season. So even though I'm not going to include season in my explanation of how to predict electricity, I need to tell the client that what a horrible word, electricity, because they deserve to know that I didn't just forget about it or ignore it. I actually looked at it and found that there wasn't an effect. Now I'm going to put that prediction equation in. It doesn't look too bad, but those numbers right here, this 27, that's going to be really hard for anyone who's not a super nerdy mathematician to really make sense of this number. So I'm going to say, as you can see in the picture above, that picture is going to help cover a whole bunch of wording that I could spend paragraphs on trying to explain. No, just look at the picture. And so I'm going to mention, for the low range, more rain decreases electricity. But for the super, super high range, it'll actually go up and as high. So reading this and looking at a picture, a client's going to get a really good feel for what is the effect of rain on electricity. And I'm going to even try to go a step further than just describing these values and try to describe why these effects are happening. Is it because here people are turning off air conditioners and then after that they're turning on their heater? For students who've grown up in Laramie, an air conditioner is a unit that is designed to actually make things get colder. If you want more research on that, you can Wikipedia air conditioner. But even though I might be wrong, just suggesting some ideas of why this might happen shows that I've really thought deeply about the meaning here and what it is that we're trying to predict and what it is we're using to predict and what all that means. And for me as a grader, the teacher, I look at that and say, okay, they totally get what's going on. Not just mathematically, because here's the math, but also intuitively, instinctively, they're understanding what the question really is about. Now, there's no way that this is a full report. I haven't shown residuals or talked about how those residuals are looking good. I haven't talked about how I use the program R and needs an intro, conclusion. I mean, there's a lot missing. But this here gives you an idea of how do you describe something that's curving? How do I use these numbers? And how do I make it so that a client can understand what's going on? I think, though, we ought to do one more example before we call this chapter good.